All right, let's look at the equation of a line that is perpendicular to 4x minus 3y plus 2, and it passes through negative 3, negative 1. Now, the equation of a line generally requires two things. It requires one, a gradient, and the second thing it requires is a coordinate. We're actually in a good spot here because we have the coordinate. It passes through negative 3, negative 1. That is our coordinate, so that is done. We just need the gradient of the line. Now, the gradient in this case, it is perpendicular to 4x minus 3y plus 2 is equal to 0. So from that equation, we need to get the gradient essentially that is perpendicular to that. This is the line we are dealing with. Anytime we have an equation of a line and we need a gradient, we need to get it in the form y equals mx plus b, where m, the coefficient of x, is going to be the gradient. This is going to require me to rearrange what I have in question. I'm going to need to rearrange it so that it looks like that. The best way to do that is to make y the subject. I'm going to do that by adding 3y to both sides. I'm going to solve it like an equation. These will cancel. So I'm going to end up with 3y is equal to 4x plus 2. Now you may notice that I've swapped the sides that I have my 3y on. That is okay. When two things are equal to each other, it means they're both the same. So that is the same as 4x plus 2 equals 3y. I'm just going to write it with my 3y on the left just because it looks a little bit neater. It's generally how I prefer to do things. Now we see it is very similar to this form here. The problem is this 3. I need to get rid of the 3. My gradient of this line is not 4. I need to get rid of that 3. And to do that, I will divide everything in this equation by 3. Because we're dividing both sides of my equal sign by 3. So it becomes y is equal to 4 over 3x plus 2 over 3. That means that the gradient of this line is 4 over 3. That's the gradient of the line I've been given. But we want the equation of a line that is perpendicular to that. And what we remember in class is that perpendicular gradients, what great handwriting by me, multiply to give negative 1. So we have this gradient from the first line, times the gradient I want to find. That is going to be equal to negative 1. So I need to solve this equation I've just created in order to find out my second gradient, my perpendicular one. And I can do this, believe it or not, by dividing both sides by 4 over 3. And I can do that in the calculator. And it's going to just straight up give me what the answer is going to be. And it's going to be negative 3 over 4. So you can just type that straight in. It's going to give you the answer. If you wanted to do it the old-fashioned way, you have 4 over 3 times m2, it's negative 1. I can times both sides of my equation by 3. 4m2 is equal to negative 3. And then divide both sides by 4. Both things will give you the same result. So now I've got the gradient that I'm after. I've got the gradient and I've got my coordinate. I need to find the equation of my new line. The best way we can look at this is through the following. Y minus y1 is equal to mx minus x1. And that's my alarm telling me I need to do this video, so excuse me for the next 3 seconds. Now I have this equation. This one will always give you the line that we're after. We have my coordinate, we have my gradient, I need to substitute it into here. My y1 from here is negative 1. So it's going to be y minus negative 1 is equal to negative 3 over 4 x minus negative 3. It's always good just to put it in, just so you don't confuse your negatives and don't make any mistakes. So working with my negatives, we've got y plus 1 equals negative 3 over 4 x plus 3. From here, we can go in two different directions. The first direction is writing my answer in general form. Now, both of these are correct, but the answer that is given to you may be different depending on how the question is asked you to give your answer. General form is when everything in your equation is on the same side of the equal sign. The other way is giving it as y equals mx plus b, gradient intercept form. Both of those are acceptable, and I'm going to run through how I could get both of those answers. So let's just do the second one first. It's a little bit easier. I'm going to expand my gradient through that set of brackets. Negative 3 over 4x minus 9 over 4. I'm then going to subtract 1 from both sides. So we have y is equal to negative 3 over 4x minus 13 over 4. And that is my answer. I am done. There is nothing else I need to do. Gradient intercept form. I've got my gradient, I've got my y-intercept. That is the equation of a line perpendicular to that line there and passes through that point. If you want it in general form, all of these things are going to be on the same side. Now, with my previous one, I can still expand through, and in fact, I'm actually going to do so just to show you. So we're 3 over 4x minus 9 over 4. I then need to get rid of these denominators. And to do that, I'm going to multiply both sides of the equation by 4. That means I'm going to multiply y plus 1 by 4, which is going to give me 4y plus 4. And the other side, negative 3/4 times 4, is going to be negative 3x. And negative 9 over 4 times 4 is just going to be negative 9. So I've got rid of those denominators. Then I want to push everything on the same side. So I'm going to add 3x to both sides, and I add 9 to both sides. So I've got 4y plus 3x plus 13 is equal to 0. Two different equations of a line. I prefer method 2. I prefer leaving it like this. It doesn't matter that there's fractions, but these are the steps you will use every single time. It doesn't matter what else you have. That is how you'll find the equation of a line through a point with a gradient that's either perpendicular or whatever it may be.